During the distillation process, a liquid mixture is separated by vaporizing one or more components of the mixture, and then the vapors are condensed. In this part, we're going to look at how a binary liquid mixture, that is, a mixture that has two components, can be separated into a lighter component and a heavier component. We've set up a laboratory demonstration to do this. In order to separate the components of a liquid mixture, a distillation system must have a container for the liquid mixture, a condenser. This one consists of an inner tube for the vapors and an outer tube with cooling water running through it, a receiver to collect the liquid leaving the condenser, and a source of heat. We'll use an electric heater. The liquid mixture we'll use consists of 50% pentane and 50% cyclohexane. These components have boiling points that are relatively far apart. At atmospheric pressure, the boiling point of pentane is approximately 96 degrees Fahrenheit, and the boiling point of cyclohexane is approximately 177 degrees Fahrenheit. In this example, the pentane is the lighter component. Its boiling point is lower than that of cyclohexane. The cyclohexane is the heavier component, and it has a higher boiling point. As temperature increases and the mixture's initial boiling point is reached, the lighter component starts to boil and vaporize. But because the heavier component has some vapor pressure at this temperature, some of it also vaporizes. The vapors condense in the condenser, and liquid starts to collect in the receiver. When the distillation process is complete, we can analyze the contents of both the receiver and the container. The mixture in the receiver is primarily pentane, but there is some cyclohexane. The mixture in the container, on the other hand, is mostly cyclohexane, with a small amount of pentane. During the process, a large part of the lighter component vaporized, while a small part of the heavier component also vaporized. If we were to repeat the process and distill the liquid in the receiver, we would get a higher concentration of the lighter product and a lower concentration of the heavier product. In this part, we'll look at batch distillation processes. A batch process is designed to distill a fixed amount of liquid. After a certain amount of mixture has been separated and its components have been removed from the system, another batch of mixture is loaded into the system and separated. There are two types of batch process systems, a single batch system and a successive batch system. Let's look at an illustration of a simplified single batch system. This system consists of a container called a still, which holds the liquid mixture, a condenser which has cooling water pumped through it, a heat source to boil the liquid mixture, and a receiver which will hold the condensed vapor. In this example, we'll use a liquid mixture of 50% water and 50% methanol. When the mixture is heated, it begins to boil. The vapors produced by the boiling liquid leave the still through a tube and enter the condenser. As the vapors flow through the condenser, they're cooled and turned back into liquid. The liquid then flows into the receiver. The vapor that's collected and condensed is called the overhead product. In this example, the overhead product contains approximately 80% of the lighter, low boiling point substance, methanol, and 20% of the heavier substance, water. The liquid that's left behind is called the bottoms product. The bottoms product in this example contains approximately 80% of the heavier, high boiling point substance, water, and 20% of the lighter substance, methanol. So you can see that a single batch system does not produce a pure separation. In other words, the overhead product contains some of the heavier component, and the bottoms product contains some of the lighter component. This can be referred to as overlap. To reduce the amount of overlap, the process can be repeated. For example, this is a successive batch system. This system has two stills, two condensers, and one receiver. The condensed vapors from the first still flow into the second still. The liquid in the second still is then heated until it boils. The overhead product from the second still contains more of the lighter component and less of the heavier component than the original overhead product did. By repeating the process, successive batch distillation produces a purer overhead product than single batch distillation. If a third still were added, an even purer overhead product could be produced. In this part, we're going to look at a continuous distillation process. A continuous distillation process is designed to distill a mixture that's fed to the system continuously and to produce products with a minimum amount of overlap. The products are removed continuously as more of the original mixture is fed to the system. Let's look at an illustration to see how it's done. This continuous distillation process system has 3 containers or stills, 1 heat source to boil the liquid mixture, 1 condenser, and 1 receiver to collect the condensed vapor. A feed line continuously supplies the system with a liquid mixture. During operation, heat is applied to the first still to boil the mixture. The vapors produced in this still rise and move into the second still. Because the liquid in the second still is cooler than the entering vapors, the heavier component of the vapors condenses. At the same time, heat from the incoming vapors transfers into the liquid in the second still, causing the lighter component of the liquid to vaporize. These vapors then move on to the third still, while some of the condensed liquid flows back to the first still. The same thing happens in the third still. The heavier component of the incoming vapors condenses. The lighter component of the liquid vaporizes, and some of the condensed liquid flows back to the second still. As the process continues, more and more of the lighter component moves toward the last still. From there, the vapors rise and move to the condenser, where they're condensed to form the overhead product. At the same time, more and more of the heavier component of the mixture condenses and flows back to the first still, where it's drawn off as the bottom's product. That's basically how a continuous distillation process works. Now remember, we're looking at a simplified illustration of a laboratory system. The actual equipment in your plant will be quite different. In this topic, we looked at the distillation process. We saw a demonstration and illustrations of a simple distillation process. We also looked at examples of 2 types of distillation process systems, batch and continuous.